Hi, Calla. Hopefully this isn't playing twice because I think I hit the wrong button at some point here. But I think I'm starting over, so I'll start over. Um, I'm going to try to walk you through some of these problems on the assignment that you left me. I don't have your textbook, and I'm not really aware of, sort of where you are in the course, what formulas you've been given, and what exactly they're, expecting you to do on these questions. So I have to kind of make my best guess there. So hopefully I can just kind of fill in some blanks for you for most of the assignment. And then if you have a chance to read through your textbook or work with your prof or visit the Math Help Center, then you might be able to fill in some of those other blanks and get the complete picture. Especially at the Math Help Center, because I imagine if they have those blocks of time, they probably have seen lots of these questions already and are really familiar with what you're expected to do to answer them. So for the first question, for number 3 that I've got showing here, the 85% observed rate from the observation, that's what they call a proportion. And so we call that p hat. And that proportion is 85%. So that's a prediction that lets us predict, how many out of a certain other sample should follow suit and should act in the same manner. Now, in this question, I don't think you need it, but in other questions, when you're working with proportional probability, it's good to know the proportion that will do something, but it's also good to know the proportion that won't, and we call that Q hat. And that's really just the complement. So whatever adds up to 100 with the P is your Q. Okay, I don't think we need that for this question though. So for this question, if we have 523, then our predicted probability would be that 523, 85% of them would wash their hands. And I think that comes out to 400 and something. I think I calculated it, about 444 people. So our predicted, based on our observations, is 444. Now, if we actually, from the actual, or from the people who are reporting that they're washing their hands, we have 518 out of the 523 reporting that they're washing their hands. That's a much higher percent. That's 99%. So that would lead me to believe that that there's some kind of a bias in this particular survey, in this questionnaire, and that bias is a response bias that people don't want to admit that they are not washing their hands when they're leaving the bathroom. Just like people didn't want to admit that they were going to vote for Donald Trump, and then the election turned out to be, opposite to what the forecasters predicted from their surveys and their polls. So I think from what you can conclude in this case, I think they want you to explain in words that the predicted from the observations and the actual survey results from the sample are quite significantly different, and that there's probably a bias in this case that would prevent people from reporting that they hadn't washed their hands due to embarrassment. So I think that's what they're getting at for number 3. So if we have a look at the next slide, for question 4, we're looking at this question about the window seat. And the best point estimate of the population, proportion A, is again our p hat, and it's just a ratio, and so 492 people out of the 806 reported that they prefer the window seat. So that's more than 50%. Let me see what it is. Oh, I have to turn my calculator on first. Yeah, about 55%, 54.8%. Okay. So that would answer question A. For question B, you want to use a formula there, and you'll find that in your book. We're going to use the z value over 2 times the square root of p hat q hat. And that's where that q hat comes in, because that would be the q that you would get if you did the complement, 1 minus 54.8%. You'll get the rest of it for q over n, okay? So in this case, our n is 806. We know our p, we know our q. The only thing that you don't have in order to calculate the error is the z. And the z comes from your z chart. And on the bottom of your z chart, there's a little box, and it will give you, trying to think how they word it, but I think it's 0.001, 0.005, and 0.01 or something like that. And they give you certain values. 1.645 is one of the values. I'm trying to do this from memory because I don't have a Z chart in front of me. 2.06 or something like that. I can't remember the rest of the values, unfortunately, but you'll see that chart there. And what it is it's giving you the Z values for those different levels of confidence. So if it's a 99% level of confidence, then you're looking for the tail to have only 1% in it. And so you would want to look at the Z value. The Z value that's going to go in here is going to be that for the 99% confidence interval from that box. So where you only have the Z of the 1%. And in that case, it's 0.005 because you're taking that 1% and dividing it between the left and the right tail. So that's the value you put in there. I think there's one that's 1.9, 9 something something. And I just don't have the values here in front of me. I don't have, all my books are at Trent there. So all you're going to do is fill those values in. This is the square root here. And fill in the numbers that we already have, and you'll get your error, and that will answer question B for you. So constructing the confidence interval for C, if I can squeeze it in here, your confidence interval looks like this. And again, you're going to find this formula in your textbook. Once you've calculated your error, it's your proportion, which is from here, minus the error that you get in part B. And then this P just stays as P because it says that the P is going to be greater than this value and less than this value in order for you to be in that certain confidence interval. And on the right-hand side, you're just going to take the P proportion again, this number, plus your error from B, and that's your confidence interval. So it might look something like, 1.65. This number won't be accurate for your answers, but you'll end up with something looking like that, where you have real numbers either side of the P, and that's all they're looking for, okay? And so for D, write a statement that correctly interprets the confidence interval. I think if you go to your textbook for that, you'll see an example where they've actually written a statement, and it's just saying, therefore, we know within, if P is within this range, then we're 99% confident that, and that's all you need to do for that statement, okay? So you can probably just directly copy that from your textbook. So just to keep these videos manageable and to make it easier to upload, I'm going to just try to do 1 or 2 questions at a time when I send them over. So I'll stop there, and I'm going to start on a new video for number 6 and 7.